All right, this is exciting. We're starting a new unit. This one is about angles and angle relationships. So let's get right into it. So you've got your new set of guided notes, and anything that you need to fill in, make sure you fill in as we go. So first of all, classification of angles. And some of these you've already seen before, if not all of them. Anyhow, an acute angle is just an angle that measures less than 90 degrees. A right angle is an angle whose measure is exactly 90 degrees. An obtuse angle is an angle that is bigger than 90 degrees but less than 180 degrees. And then finally, if we have a straight angle, that's just a straight line which represents a 180-degree angle. So keep that in mind. So if we take a look at this shape right here, looking at angle A, that looks like it's a 90-degree angle, so that would be a right angle, right? So we're going to, if we were doing this on Alex, we would just mark that box right there. Angle B is 100 degrees, which makes that an acute angle, or excuse me, an obtuse angle. I almost said acute, but it's bigger than 90, right? And then angle C, it is 60 degrees, so that would make that an acute angle. And angle D is 110, so that would be another obtuse angle. All right, keep moving here. There's a couple of types of angles that you will encounter. First of all, adjacent angles. Adjacent angles are angles that are right next to each other and that share a common side. Looks like this. And when you see angles like that, sometimes we ask you questions about one angle versus the other angle, how much they are, how much they equal, and that type of thing. So for another definition we want to give you is complementary angles. These are two adjacent angles most of the time, but they don't have to be adjacent. But anyhow, two adjacent complementary angles are two angles that are next to each other like this that add up to 90 degrees. So 60 plus 30 is 90 degrees. So that's how we know that they are complementary. Now we have a couple of angles over here that are not adjacent, but they still add up to 90 degrees, so they would be adjacent but non-complementary angles. All right, moving along. If we have a couple of angles that are adjacent to each other that add up to 180 degrees like this, that is called supplementary angles, and they're adjacent. If we have two angles that add up to 180 but are not adjacent to each other, that would be non-adjacent supplementary angles. Because regardless of whether or not they touch, their two angle measures would be equal to 180 degrees. That's 180. All right, let's move along then. So an angle measures 85 degrees. What is the measure of its supplement? Well, we just learned from the previous page that supplementary angles add up to 180 degrees, right? So if I want to find the supplement of another angle, then I just subtract that angle from 85, or subtract from 180, sorry, like that. And 180 minus 85 would end up being 95 degrees. All right, an angle measures 58 degrees. What is the measure of its complement? So to find its complement, we're just going to subtract it from 90. Okay, so 90 minus 58 that would equal 32 degrees. Look at that. So the complementary angle to 58 is 32 degrees. All right, here's another kind of a problem you might see. It'll show a diagram or a picture like this and say, find the value of x. Well, you know that because of that little square box that's in there, you know that these two angles add up to 90 degrees. So x plus 69 equals 90 degrees. And then you just have to subtract 69 from both sides. And 90 minus 69 comes out to be 21 degrees. So x equals 21 degrees. All right, here's two angles that are adjacent, and because they make a straight angle, they add up to 180 degrees. And so all we have to do to find x is just do 180 minus 85. And then when you subtract 85, you get 95. So the supplementary angle to 85 is 95, and the two angles add up to 180. Okay, so in this figure, this one will get a little bit more involved. So what we're telling you is that angle 2 right there equals x plus 22. Meanwhile, angle 1 is equal to 3x. And we know that if we add these two angles together, that you would get a total of 90 degrees for your answer. So we're going to look at this a little closer. We've got some x terms here, two of them. If we combine those x terms, we can get 4x plus 22 equals 90. Okay, and now all we have to do is, if I got to write that a little neater, that's 4x. Let me clean that up just a little bit. So 4x plus 22 equals 90. So if we subtract 22 from both sides, like this, 90 minus 22 would equal 68. And that is equal to 4x. All right, so now all we have to do is divide by 4. So I'm going to get my calculator. So 68 minus 68 divided by 4. So divided by 4. So x equals 17 degrees. So if we look at our angles once again, angle 1 was 3x's though, so we've got to do 3 times 17, which ends up being 51. And then the last one, you've got 17 plus 22 to find that one. So 17 plus 22, that comes out to be 39 degrees. And you see how if you added them together, 39 plus 51, you would indeed get 90 degrees. Okay, one or two last concepts here. Whenever you have two lines that intersect each other like this, doesn't matter what angle that they cross each other, then it forms 4 angles. If you notice, the angles straight across from this intersection, like 1 and 3 or 4 and 2, have the same angle measurement as the angle across from them. So, two angles opposite each other when 2 lines cross are called vertical angles. And these angles are congruent. Okay, so you'll see some problems where you get a diagram like this, and they'll say, okay, well, if angle 1 is 38 degrees, how much is angle 2? Okay, so 38. And we know that angle 1 and angle 2 add up to 180. So if you do 180 minus 38, you will get 142 degrees. So I know that these bigger angles are 142 degrees. So 142 up on top, 142 on the bottom like that, and 38 over there. So you found all 4 angles by just getting one of them to start with. Okay, next. Given this figure, they want us to find x and z. Well, z is pretty easy. If you go straight across from the intersection here, we have an example of vertical angles with that answer. So we know that z is 97. We can also do this. We can say that this angle up here is equal to 180 minus 97. (180 minus 97). So that might be a little easier to visualize. 180 minus 97. And so if I do 180 minus 97, what do I get? Well, I got to borrow one from 18 and give us 17 and bring that one over. 10 minus 7 is 3, and 17 minus 9 is 8. So that's equal to 83. Now, if I set 6x minus 19 equal to 83, now I can solve for x and find its value. So plus 19 and 6x equals 9, 10, 11, 12, 2, and 3, 1, 8, 9, 10. 102, that's a little different, a little better number, right? So divide by 6, and I'm going to do 102 divided by 6, and I end up with x equals 17. So there's our two numbers. X is 17 and z is 97. Okay, so our assignment then is going to be number 88, angle relationships. Remember to show your work on box paper and have fun. This is a fun little assignment. Thank you very much.